Bedrock Linux is one of the most fascinating and unconventional Linux projects ever created. While almost every Linux distribution asks users to pick one ecosystem and stay within its boundaries, Bedrock Linux completely ignores that traditional rule. Instead of forcing you to choose between Ubuntu, Arch, Debian, Fedora, Gentoo, Void, Alpine, or any other distribution, Bedrock Linux attempts something that sounds almost impossible. It allows you to combine multiple Linux distributions into one operating system and use them together as if they were parts of a single unified system. Imagine running Arch's bleeding edge packages, Debian's legendary stability, Ubuntu's massive software repositories, Gentoo's customization, and Alpine's lightweight tools all on the same installation without constantly rebooting or maintaining multiple virtual machines. That is the ambitious vision behind Bedrock Linux, and for many Linux enthusiasts, it feels like the ultimate operating system experiment. To understand why Bedrock Linux exists, you first have to understand the problem it is trying to solve. Every Linux distribution has strengths and weaknesses. Ubuntu offers incredible hardware compatibility and beginner-friendly software repositories. Arch Linux gives users the newest software almost immediately after release. Debian focuses on rock-solid stability. Fedora often introduces cutting-edge Linux technologies before anyone else. Gentoo allows users to compile everything specifically for their hardware. Void Linux provides a lightweight and independent alternative with its own run-it-init system. Linux users have debated for decades about which distro is the best, but Bedrock Linux asks a completely different question. What if you never had to choose in the first place? Instead of replacing your favorite distribution, Bedrock Linux transforms it into the foundation of a much larger ecosystem. The project introduces the idea of strata, which are essentially separate Linux distributions living together inside one operating system. Each stratum keeps its own package manager, libraries, binaries, and software repositories, while Bedrock provides the tools necessary to make them work together seamlessly. From the user's perspective, applications from different distributions can coexist on the same desktop, almost as if they came from the same operating system. Imagine installing Arch Linux packages, using Pacman Ubuntu packages, using apt Fedora packages, using and Alpine packages using APK, all without leaving your current desktop session. Instead of running everything inside isolated containers or virtual machines, these distributions become interconnected. A program installed from Arch can work alongside another installed from Debian, while your shell environment remains unified. It feels almost like creating your own custom Linux distribution assembled from the best parts of every major project. The installation process itself is unlike traditional Linux installations. Rather than downloading Bedrock as a standalone operating system, users generally begin with an existing Linux distribution. Once that distribution is installed, Bedrock converts it into a Bedrock system. Afterward, additional distributions can be added as new strata whenever the user wants. One of Bedrock Linux's biggest advantages is software availability. Sometimes a package is outdated in one distribution but current in another. Sometimes proprietary software officially supports Ubuntu but not Fedora. Developers may prefer Arch's newest compiler, while system administrators trust Debian's stable server tools. Bedrock allows users to install each application from whichever distribution provides the best version. Developers find this concept especially attractive because software development often requires different environments. One programming project may depend on an older compiler available in G, while another needs the latest LLVM release from Arch. A third project may rely on Fedora's newer libraries. Bedrock allows these environments to coexist naturally on the same machine. This reduces complexity while giving developers incredible flexibility. For Linux enthusiasts who enjoy experimenting, Bedrock feels like an endless playground. You can compare package managers side by side, benchmark applications across distributions, or test software in multiple environments without rebooting. Curious whether Fedora's package performs differently than Arch's version. Run Alpine's tiny utilities alongside Ubuntu's desktop software. No problem. The possibilities encourage exploration in ways traditional Linux distributions simply cannot. Of course, such power comes with complexity. Bedrock Linux is not designed primarily for beginners. Every Linux distribution has different assumptions about system configuration, file system layouts, package initialization methods, and update cycles. Bedrock works hard to hide these differences, but users still need a solid understanding of Linux fundamentals. When multiple package managers are modifying different parts of the same system, troubleshooting can become far more complicated than on a standard distribution. Compatibility is another challenge. While Bedrock supports many popular Linux distributions, not every combination works perfectly. Some packages assume complete control over the operating system, while others expect specific versions of shared libraries. Occasionally, conflicts appear that require manual intervention. The Bedrock developers continuously improve compatibility, but combining independent operating systems is an enormously difficult engineering problem. Performance, however, is surprisingly good because Bedrock does not rely on traditional virtualization. Applications generally run at native speed. There is no virtual machine overhead consuming extra CPU or memory. Programs execute directly on the host kernel while using their own distributions used. This gives users much of the flexibility of containers without sacrificing the responsiveness of a normal Linux installation. Security follows traditional Linux principles but requires extra awareness. Since multiple package managers independently install and update software, users must ensure every stratum remains current. Forgetting to update one distribution could leave outdated software alongside fully patched applications from another. Managing several ecosystems naturally requires more attention than maintaining a single distribution. The Linux community has mixed opinions about Bedrock Linux, and that is part of what makes it so interesting. Some see it as one of the most innovative Linux experiments ever created, pushing the boundaries of what an operating system can be. Others believe it introduces unnecessary complexity into a platform already known for flexibility. Critics argue that containers, Flatpak, Snap, or virtual machines already solve many compatibility problems. Supporters counter that none of those technologies provide the same seamless integration of multiple complete Linux distributions sharing one unified desktop environment. Perhaps the most remarkable thing about Bedrock Linux is the philosophy it represents. Most operating systems define themselves by drawing boundaries. Windows is Windows. macOS is macOS. Ubuntu is Ubuntu. Arch is Arch. Bedrock questions that entire way of thinking. Instead of treating distributions as isolated worlds competing against each other, it treats them as collections of tools that can cooperate. It transforms Linux from a choice between ecosystems into a platform where ecosystems can coexist. Will Bedrock Linux ever replace mainstream distributions? Probably not. Most users simply want an operating system that works out of the box with minimal maintenance, and traditional distributions already accomplish that extremely well. Bedrock demands curiosity, patience, and a willingness to experiment. It targets power users rather than casual desktop users. Yet, its importance goes far beyond market share. It demonstrates just how flexible Linux truly is. The fact that one project can successfully merge multiple independent operating systems into a single functioning environment showcases the incredible modularity of the Linux ecosystem. Whether you actually install Bedrock Linux or simply admire the engineering behind it, the project serves as a reminder that Linux continues to evolve in unexpected ways. It challenges long-held assumptions, encourages experimentation, and proves that in the open source world, even ideas that initially sound impossible can become reality. Bedrock Linux may never become the default operating system for millions of people, but it stands as one of the boldest examples of Linux innovation, showing that sometimes the future is not about choosing the best distribution, but about building a supersystem where every distribution can contribute its greatest strengths.